Okay, Assalamualaikum and a good day to all. Okay, so this is a recorded lecture, okay, for the line integral for the second part. Okay, so without further ado, I'm going to start on the new subtopic, okay, under the line integral. Okay, so for this topic, please refer to page number 219, okay, from ebook Paul Dawkins. Okay, the line integral for the vector field uh, we can find out with respect to different variables such as stated here, the line integral of f with respect to x is given by this integral c fxy dx, okay, such that equal to this integral from limit a to b for xt yt multiply with x prime t dt. So if we have different parameter, which means that on different variable, okay, such as here, line integral of f with respect to y variable, okay, is given as here. So as you can see, what is the difference between the first and the second one is the dx and dy will be multiplied by its corresponding first derivative. Okay, so this line integral basically appear together, okay, in terms of x and y. And to see details, we are going to consider this example 1. Okay, so here we have to evaluate this line integral whereby this is the function, okay, with respect to x variable as shown here as dx, where the problem C is the line segment from this point x0, y2 to the second point as x1, y equal to 4. Okay, so similar to the one that you have studied before, we will begin by finding the parametric equation. Okay, so since this is a line segment, so we refer to the guideline of the parametric equation. Okay, so we can find out that this RT equal to 1 minus T multiplied with the x coordinate plus T times with the second coordinate. Okay, so I hope that you still remember how to find this parametric equation. Okay, so we refer to the guideline for the line segment. We have 1 minus T. Okay, 1 minus T times with your points 0 and 2. Okay, plus T times with your second point as 1, 4. Okay, so we have to open this bracket. Okay, and then we combine between x coordinate combined with x coordinate, and then y coordinate will be combined with y coordinate. Okay, so first we have 0 for x, then y we have 2 minus 2t. Okay, then plus t 40. Okay, so x will be combined with x, then we get 0 plus t as t. Y will be combined with y. Okay, then we have 2 plus 2t, which is here. Okay, so this is the parametric equation. Then the limit for t is from 0 to 1. Okay, because the limit for this line segment problem always been 0 to 1. So the line integral with respect to this y and then x variable as given here. Okay, so we have this function sine pi y, then y are squared. So everything in terms of y and x must be changed into parametric form. Okay, so this is our yt. Then this is our xt. Okay, so sine pi y must be changed into parametric. Okay, so we have to change sine pi where y is 2 plus 2t. So that's why here we have to change to parametric form. Then this yx squared also must be changed to y and then times x squared as t squared. Okay, and then remember that whatever we have here as dy and dx, they must be multiplied with their first derivative. Okay. Okay. So since we have here yt equal to 2 plus 2t, so and then we find derivative, which is dy dt, we have 2. And for x, we have t, so the first derivative is equal to 1. Right? Okay, so our dy dt is equal to 2. So dy is 2 dt. For x, our dx dt is equal to 1. So that means dx is dt. Okay, just times. Okay, so this dy, replace it with this 2 dt. This dx, we replace it with dt. Okay, so the changes is shown here. Okay, so here, before we find the integral value, you are supposed to times out. Okay, so this is a constant too, so you can make it in front. And then we have to expand this bracket for the second part. Open this bracket, times out. Okay, so this becomes 2t squared plus 2t power 3. Okay, these two constant, so we can write in front here. Then we do the integration with respect to sign. Okay, so the answer for this integration, okay, because this is in terms of the angle, we are going to integrate with respect to t. Okay, so we have this answer. Integration for sine will be negative cos. Okay, and then there's a 2, then the constant will be cancelled out. Okay, then we got this answer for the simplification. Okay, so basically we have direct answer, which means that you can refer from the formula list. Okay, and then you're supposed to evaluate when t equal to 1 and when t equal to 0. Okay, same goes on the second part when t equal to 1 and when t equal to 0. Okay, so final answer, you will get 7/6. Okay, for this part, if you are not clear how to do the direct integration, okay, please consult with me through WhatsApp. Okay, now we will move to the next subtopic, which is line integral in terms of dr. Okay, it is line integral, but we have a different formula for the problem. It's stated here that the line integral of this vector field along C, okay, is given by this r f dot dr that is equal to this line integral from A to B for FRT times R prime T dt. Okay, as you can see here, we have this dot product. Okay, this is operation, one of the operation in the vector field. Okay, dot product means that I hope you still remember dot product means we have to multiply in terms of the scalar value only. Okay, so the line integral for this problem, when we have this dot product between the vector field and the R will be equivalent to this one. Okay, RT is your parametric equation. So this line integral means when we substitute RT into your vector field and then we find the dot product with its derivative of parametric equation. Okay, R prime T means first derivative of the parametric equation. Okay, so here we are going to see the one of the example. Okay, we see here this is the line integral f dot dr where the vector field is given here. Okay, so we have vector field in terms of 3-dimensional and C is the curve given by this parametric equation. Okay, so this example one is straightforward because the parametric equation for C is given. Okay, so if it's not given, then you need to find out. Okay, so how to find out? Just refer to the guideline how to find the parametric equation. Okay, so we are going to use this parametric equation. So start with this parametric RT. Okay. When we refer to this parametric, that it is, we can see that this is your X. Okay, this is your Y, this is your Z. XT, YT, ZT. Okay, correspondingly is given. Okay, so that means the meaning of FRT. Okay, this means we include your parametric into your vector field. So that means everything that we have here in terms of X, Y, Z, okay, Z and 4XY should be changed into parametric form. Okay, so I'm working here. First one, we have 8. So X squared is your, in terms of T, would be T squared. Because our X is T. Okay, and then Y. Y is T squared, so we have T squared. Okay, Z is T to the power 3. Okay, so this is 8X, Y, Z. Okay, so the vector I will remain the same thing. Okay, I. Then we do similarly for 5Z. So Z is T3, T power 3. Then we have vector J. Then we have minus 4. Okay, X is T. Y is T squared. Then we have vector K. Okay, next step is you need to simplify. Okay, T power 2 times T power 2. Then we have T to the power 4. T to the power 4 times T to the power 3. Then we have T to the power 7. Then we have 8 T to the power 7 I. Okay, then this is remained the same thing. This will be minus 4T power 3. Okay, so this is our FRT. Okay, so remember just now, when we want to evaluate this integral, f dot dr, okay, so it will be equal to your integral f RT times, okay, dot product with the first derivative. Okay, so we have find out what is FRT, and then next step we need to know what is your R prime T. R prime T means your first derivative of the parametric equation. Okay, so this is RT. So just find out directly. We have to differentiate with respect to T. Okay, differentiate T, we get 1. Okay, 1. Then we have 1I. Differentiate T squared, we will get 2T. Okay, then we have J. Differentiate T power 3, we have 3T squared. Then we have vector K. Okay, so this is the derivative of the parametric equation. Okay, so we have this FRT and we have R prime T, and then we need to do this dot product. Okay, what is the meaning of that product? The scalar part will be multiplied the scalar part correspondingly. Okay, so FRT dot R prime T dt. Okay, we find out the dot product. Okay, that means let's look at here. Okay, here dot product, we don't going to take, okay, the vector. We just take the scalar. This is the scalar part without the vector symbol. Okay, FRT, this is 1 in terms of I, but we are going to multiply the scalar only. So first we are going to multiply with this one. This is 1 here. Okay, So there's 1i. So just take 1 times 8t power 7. Then we have 8t power 7. So take notes, this is the product. So don't write the vector. It should be the multiplication in terms of the scalar. Okay, next, second part. We have 5t power 3. So we are going to multiply with this 2t. Okay, 5t power 3 times 2t. So 5 times 2 is 10. T power 1 times t to the power 3, we have t to the power 4. Okay, so again, leave the j without vector symbol. Okay, next one. We have this negative 4t power 3. So then we are supposed to multiply with this one. Negative 4 times 3, we have negative 12. T power 2 times t power 3, we have t to the power 5. Okay, as you can see here, the power at t is different one. So there is nothing that we can combine. This is the simplest form already. Okay, so that means this integral would be, okay, I'm going to continue here. The integral of this answer, 8t power 7 plus 10t to the power 4 minus 12t to the power 5. Okay, then from limit 0 to 1. Okay, so this function is very simple. Then I hope that you know how to do the integration directly. So we have t to the power 8 plus 2 to the power 5 minus 2 to the power 6. And then you have to evaluate when t0 and t1. Okay, so check that your final answer must be equal to 1. Okay, now we are going to see the conservative vector field. Okay, so this conservative vector field is the situation that we can use to identify whether the path in the vector field is independent or not. Okay, so to check whether the path is independent, we can check about the potential function for the vector field. Okay, so I'm going to read the one of the theorem which is important in this vector field. First one, okay, let the vector field given here, PQ can be any functions, and the vector field is an open and simply connected region D, then if P and Q have continuous first order partial derivative in the region D, okay, then the partial derivative is given here. So this stated that partial derivative of P with respect to Y will be equal to partial derivative of Q with respect to X. So if they are equal, so we can say that this vector field is conservative vector. So if it's not equal, we can say that this vector field is not conservative vector. Okay, so simple. So that means we, in order to check whether the vector field is conservative or not, we have to find the partial derivative and compare. Okay, whether it is equal or not. Okay, so I'm going to take example. Okay, I'm going to choose here example 1b. Okay, so the problem just now, or the question state to check whether this vector field is conservative or not. Okay, so we have this vector field. We know that this is your P, this is your Q. How to check? The one that is with I is your P, the one with G is your Q. Okay, P, because general form given as PI plus QJ. Okay, PI plus QJ. Okay, so this P, you are supposed to find the partial derivative, partial derivative. Okay, so partial derivative here, we need to do the differentiation with respect to Y. Okay, so see here. This is y, the one that I underline. This is y, this is y. Okay, now find derivative. This part very simple because we have only one y, so the other term or the other parts we can assume it as the constant. Okay, assume it as constant. Okay, something like this. I'm going to show one part and the next part. Derivative. Okay, we want to differentiate these two x e to the power xy. Okay, so what is our differentiation? We want to differentiate with respect to y. Okay, so I am using different color to differentiate. The blue one we can assume it as this constant. E is the function. So 2x and x assume as constant. Y is the variable that we want to differentiate. Okay, so you can assume how to differentiate something like this. Let's say we have 3e to the power 2y. How to differentiate with respect to y variable? Of course, this part will be multiply, right? So we got 6e to y. Okay, so something like this, similar. So this part also would be the same thing. The answer for this derivative would be 2x times x. So we have 2x squared. Then we have e x y. Okay, so the first part is very simple. Now we are going to see the other one, which is the second part. Okay, the variable that we want to differentiate, this is the function x squared, but we want to differentiate with respect to y. Okay, something like this. Then ex, we have then we have y. Okay, so I'm using different color because our with respect to variable is y. We want to differentiate with respect to y variable. Okay. So the example for this derivative, yeah. How we differentiate? Let's say 3y e 4y. Okay, something like this. Of course, something here. Okay, so take first one. We have to use chain rule basically, okay, in order to find derivative. Take the first part, which is 3y, then differentiate second one. Differentiate e 4y, we will get 4e 4y. Okay, so chain rule there will be plus. Okay, and then take second part. The second part, your second part is e 4y. Okay, then differentiate first part. Differentiate 3y, we will get 3. Okay, so we have two terms here for the answer of this derivative because we are using chain rule. Okay, so you can see there's a constant that you can combine, yeah? Okay, so we do similarly what we have here. So x squared and x here, think as a constant. E is the function. Okay, so you must have two terms because you have these kinds of similar function that we have here. First one, we take first part. Your first part is x squared, yeah? Okay, x squared. Then we have y. I'm going to separate here. This one as first part. This is as first part. So the one that not in the bracket as the second part. Okay, so here is x squared y. Take first part, yeah? Okay, differentiate the second one. X is a constant, so we have x. E, x, y. Okay, then plus. Okay, so you can compare process is the same thing, yeah? Okay, the second one, take the second bracket, second part here. The second part, take ex, y, then combine with Okay, combine with, differentiate the one in the bracket. Okay, so x squared is a constant, right? Constant. So cancel. How to differentiate? Let's say 3y. Okay, you will get the constant. So y will be removed. So we have x squared. This is times. Before that, this one, it will be times. Here and here will be multiply. Okay, so I'm going to rewrite here that derivative for x squared y, okay, is x squared y, and then we have x e x y plus, okay, x squared e x y. Okay, so this is the answer. So we combine this answer is the answer for this derivative. Okay, which is displayed here. Okay, then this one, this 2 is given here, is shown here. Okay, so we have two parts. Okay, so you have to look at when we combine, basically this one is the same form. So basically they can be combined because x squared also, then exy. Okay, so we have 2 plus 1. So 2 plus 1, you will get 3. Okay, that's why here these 3 terms can be simplified to these 2 terms. Okay, so that is the answer for partial derivative for p with respect to y. Okay, now we move to q. Okay, this q, we have to find partial derivative with respect to x. Okay, so partial derivative with respect to x. So we want to differentiate x power 3 e xy. This is the first part that we want to find the derivative. The variable is x. Okay, so x is our main variable. So let me change this notation to x power 3 e x y. Okay, so e is the function. Green white color is your constant. Okay, so this concept, because x is our main variable, okay, so that means you have to differentiate to two parts using chain rule. Okay, take first one, take the first bracket, take first bracket, take only, and then differentiate the other one. You will get e. Okay, we should write down constant first. The constant is y. Okay, constant is y. So we have y e x y. Okay, plus take the second part. Take everything in the second part, and then we differentiate the first part. Differentiate the x cube will be 3x squared. Okay, so you can see when you combine, there's nothing that we can simplify. So we really have to look at this part. Remains, there's nothing that we can simplify. Yeah. Okay, now we compare. Are we going to get partial p with respect to y? Is it equal to partial q with respect to x? Okay, we compare these two. Okay, so yes, this is equal. The one that we have here equal to the second one. Okay, so we have to conclude that since this partial derivative is equal, then we can say that this vector field is conservative vector. Okay, so that is the topics for the first video. If you have any question to ask, okay, please WhatsApp or contact me. Okay, thank you everyone.